All right, this is a bit of an interesting one. We've got different degrees in our radicals here. We've got different expressions underneath those radicals. So a lot of pitfalls here, a lot of mistakes that could be made. Let's look at a couple different approaches here. Number one, because my radicals are of different degree, I think I'd be a little bit more comfortable if I wrote those as fractional exponents. Because if we write them as, if this was a third root, I'd write this entire fraction under the third root. But because they're of different degrees, I don't want to fall into any traps with that. I think instead, I'll take this x squared to the y power, raise that to the 1/3, and then my xy that's on the bottom, I can raise that to the 1/2. Now, if you're thinking, oh, I can subtract these exponents, I can't right now because these bases are different. So I wouldn't be able to subtract 1/3 and 1/2, namely because there's a 2 here and there isn't one here. So these are different terms, they have different bases, I can't subtract them like that. But what I can do in terms of simplifying is, you know, the x's, they're the same base. This is a product and this is a product. So I can distribute, and again I'll use the air quotes, distribute the power to both parts of that product. So I get x to the 2/3 power, y to the 1/3 power, and that's written over x to the 1/2, y to the 1/2. So what does this do for me? Well, in essence, I've almost separated that power, or excuse me, that product into its two parts. Now if I look at each one of these pieces as their own separate power, I do have a common base for these two powers, and I do have a common base for these two powers. And now I can subtract those. So I can go off to the side over here and say x to the 2/3 over x to the 1/2. If I subtract these, okay, so you can pause it now and do your fraction math if you want, but the common denominator of 3 and 2 would be 6. So this is 4/6, this is 3/6. I get an overall value of 1/6 from this. Let's switch up the colors here. Y to the 1/3, y to the 1/2. Again, I have to subtract those powers. Similar, common denominator of 6. So this is 2/6 minus 3/6. I get y to the negative 1/6. So these powers simplify to here. These two powers simplify to here. So my overall value is here. X to the 1/6, y to the negative 1/6. Lots of different ways that I can go with this, and we're going to go there just so that we become more comfortable practicing these. So I'm not subtracting these, don't get me wrong, these are different bases. But because this base has a negative exponent, I'm going to move that into the denominator of a fraction. So this is x to the 1/6 over y to the 1/6. Now you'll notice that those powers are exactly the same. So since I have a fraction and I have identical powers, I can factor out that exponent. Whereas normally in the past we can take that exponent and distribute to both of these. I can also factor out the opposite of distribution. I can factor out a 1/6 as the exponent. So this is x over y to the 1/6 power. And I could leave that as my answer in exponential form, but if I wanted to write my answer in radical form, since the 6 is the denominator, this is really the 6th root of x over y. So my final answer could take on two different forms. I could have been okay with this. I could have been okay if they wanted it in exponential form initially like this, but these rules for exponents, they get applied in any number of ways in any number of orders, but we have to become more familiar with them the more we work with them here.